Good morning, students. Today, let us see distributed databases. What is a distributed database? It is a database in which not all storage devices are attached to a common processor. It may be stored in multiple computers located in the same physical location or may be dispersed over a network of interconnected computers. Let us see the architecture diagram. So you have the communication channel and you have the database for location 1, location 2 and location 3. Communication channel is used to communicate with different locations, and every system has its own memory and database. Advantage of distributed database. Reasons for building a distributed database. Sharing data. The user at one site may be able to access the data residing at other sites. Autonomy. In a distributed database, there is a global DBA for the entire system. A part of these responsibilities is delegated to local DBA for each site. Each site has its degree of control over data. Availability. If one site fails, the required data can be obtained from any other site. There are Let us see the types of distributed databases. Homogeneous distributed databases. Database at all sites have identical schema and database management system software. So you have communication channel, you have department 1, 2 and 3, and everything is having similar distributed database. For example, Oracle 9. Second type is heterogeneous distributed database. Different sites may use different schemas and database management system software. Difference in schema is a major problem for query processing here. So you have the communication channel. Department 1 is using SQL Server 2009. Department 2 is using MS Access. And Department 3 is using Oracle 9. The data can be distributed across the various storage devices in distributed data storage. The two ways are data replication and data fragmentation. Let us see what is data replication. A relation or a fragment of the relation is replicated if it is stored redundantly in two or more sites. Full replication of a relation is the case where the relation is stored at all sites. Fully redundant databases are those in which every site contains a copy of the entire database. Advantages of replication. Availability. Failure of site containing relation R does not result in unavailability of R as replicas exist. Parallelism. Queries on R may be processed by several nodes in parallel. Reduced data transfer. Relation R is available locally at each site containing a replica of R. The disadvantage of replication is increased cost of updates and increased complexity of concurrency control. Data fragmentation. The system partitions a relation into several fragments and stores each fragment at a different site. Horizontal fragmentation. So here a relation R is partitioned into number of subsets, for example R1, R2, R3 up to Rn. That is, we use a predicate Pi to construct a fragment Ra. So Ra is equal to sigma of Pi for the relation R. We reconstruct the relation R by taking the union of all the fragments. So when you make the union of all the fragments, we are getting the original R. The second type is vertical fragmentation. The schema of relation R is decomposed into several subsets of attributes. Each fragment Ra of R is defined as follows, right? Ra is equal to pi of the relation Ra of R. We reconstruct the relation R by taking the natural join of all the fragments. So R is equal to R1 natural join, R2 natural join till Rn. Let us see what is meant by data transparency. The degree to which system user may remain unaware of the details of the how and where the data items are stored in a distributed system is called data transparency. Consider transparency issues in relation to location transparency, naming transparency, replication transparency. Location transparency means being unaware of the location of data. Naming transparency means being unaware of the names of the database object. Replication transparency means being unaware of the existence of the copies. Let us see now the two types of transaction. So local transaction, global transaction. A local transaction accesses data only from sites from where the transaction is initiated. Global transaction. It accesses data from several different sites. Now let us see the distributed database architecture. So we have TC1, right, then TM1. So we have TCN and TMN. So from 1 to N we have N number of transaction coordinators and N number of transaction managers, and we can see how they are linked to each other in the case of distributed database architecture. Let us see now distributed database architecture. The system architecture, each site contains two subsystems, right? So you have transaction manager and the transaction coordinator. The transaction manager manages the execution of the transaction or sub-transaction that access data stored in a local site. Each transaction may be either a local transaction or part of a global transaction. Responsibilities: maintain a log or recovery purposes. Choose an appropriate concurrency control scheme to coordinate the concurrent execution of the transaction. Next is your transaction coordinator. The transaction coordinator coordinates the execution of the various transactions, both local as well as global, initiated at that site. Responsibilities: starting the execution of the transaction, breaking the transaction into number of sub-transactions and distributing these sub-transactions into the appropriate sites for execution. Coordinating the termination of the transaction. This may result in a transaction being committed at all sites or aborted at all sites. Distributed transaction processing. To ensure this atomicity property of distributed transaction, the transaction coordinator of T must execute a commit protocol, right? You have two-phase commit protocol and three-phase commit protocol. Two-phase commit protocol has prepare phase and commit phase. Three-phase commit protocol has prepare phase, coordinated decision phase, and commit phase. Thank you, students.